Okay, in this video we're going to be looking at the following equations that are appearing now on the screen. In my previous videos I've looked at reflection, refraction, superposition of waves, also the wave diagram, and looking at mechanical and non-mechanical waves, so check that out. If you already haven't subscribed, please subscribe. I've already done a playlist on kinematics and dynamics, so that might help you for your studies. Let's have a look at the variables that got given, and you can see that as I just mentioned on the screen now. So you've got C, which is speed of light, N is refractive index of the medium, or Nx, Vx is just the speed of light in that medium, I and R just angle of incidence and refraction, N1 and 2 just absolute refractive index, and I, which is given to you in the intensity of light equation, is intensity of energy per area unit, and R is the distance from that source. So let's have a look here at where we can use these equations. You would see a table appear now on the screen, and it's got missing values for the velocity of light in the medium and the absolute refractive index of that material. I'm going to give you the opportunity now, if you would like to pause, do it yourself, it's up to you, or if you want to see a worked example, I'm going to do air and Perspex on my next slide. So I'm going to give you the chance now to pause it. Okay, so let's have a look at air and Perspex at least. So all you need to do to find the velocity of light in that medium is have the speed of light divided by the absolute value that you got, which was 1.00028, and you'll get that large number associated in meters per second. Now for Perspex it's the same, however, instead of having the absolute refractive index of the material, the 1.00028, for Perspex you're using the velocity of light in the material, so you got 2.0 times 10 to the 8 as your bottom denominator, and you've got your refractive index for Perspex as 1.5. So if you'd like the opportunity again to pause it to do the other values, I'm giving you the opportunity now. Okay, you can see now that the values appear on the screen and it's a completed table. You may need to have these values for my next set of questions, especially the next one here. So let's have a look. You've got the path of a ray passing from air into flint glass and is shown in the diagram. A, calculate the value of the angle, and B, calculate the velocity of the light in the glass. So I'll give you the opportunity, if you'd like to do it yourself, to pause the video. Okay, let's have a look here of what we got. So for A, you got N1 sine I equals N2 sine R, and you got 1, which is the speed of light of air, so it's 1 times sine I equals 1.65 times sine 15. Rearrange the equation to make sine I alone on the left hand side, shift sign your answer, and you get 25 degrees. Now for calculating the velocity of light, you got speed of light. Now Vx came from my previous slide, and I did mention that in the table, 1.65, and you get the number associated at the bottom. Okay, so let's have a look at the next question, or looking at the practice that we're going to be doing in class. So you can see here that we've got a range of diagrams looking at a plane mirror, concave and convex mirrors. We'll be doing that in class, so don't stress. It's just here, there on the video, so you get an idea on what we're doing or may have done already. Let's have a look at the next video. So Snells Law, there's another set of diagrams there, and you can see that I've got a glass prism with a ray box example. Okay, so let's have a look at what dispersion is. And dispersion is the separation of white light into the visible spectrum using a prism. And you may have already done this in junior science, and we're doing it in class as well. So you can see there we use a single slit ray box, pass it through a prism, and you get the visible spectrum. It's pretty straightforward. In the last one, we're looking at the inverse square rule, and you can see there the different boxes are represented by the different distances away. So you got 1, a quarter, a ninth, and a 16th. Now we'll do this prac in class as well. So let me summarize what we just learnt in this video. We've discussed and touched on each of the equations given to us in the syllabus dot point. We're going to be doing a lot of these pracs in class, as it says in this syllabus dot point, and I suggest you copy these diagrams, or at least have an understanding of these diagrams before we start. If you already haven't, check out my other playlists on kinematics and dynamics. I'm going to be doing a whole range of videos in this wave and thermodynamics topic, so please subscribe, like, dislike, any feedback's positive feedback for me. Thank you for your time.